Hello, viewers. Welcome to Taxonomy Online Mathematics. Another question on calculus 3. A welder used a rectangular sheet of metal with the dimensions 5 meter by 3 meter to make an open rectangular box by removing equal squares of size A meters from each corner of the sheet. So we have to show that the volume, which is the V meter cube of the box, is given by V equals to 4A cubed minus 16A squared plus 15A. Then B, we have to find correct to the nearest whole number the maximum possible volume of the box. So first of all, identifying this to be a differentiation question, because we are going to have the use of maximum or minimum. So that will be dealing with what? Second derivative. So first of all, we need to make a sketch of the rectangular sheet that the welder will be using. So if I have this as our rectangular sheet, so if it's the rectangular sheet of metal that you want to use, we are aware that the dimension is 5 meter by 3 meters, right? Now, you decide to remove A meter square, a square of A meter, meaning we have this to be a dimension of A from the corners. So if we take away the A from this corner, same will be taken away from this corner, good. So this dimension is going to be A. Here will also be A throughout, all surrounding it. So now they say removed. So if this part is taken off, this part is removed from the metal. So you can agree with me that what we are seeing here is the net of a cube or a cuboid, which we cannot say that this area will still remain 3. We have taken away, imagine this area we are taking is 1 meter. Then it means the remaining meter become 2. Then we take away next one, meaning the 1 will give me the 3. So I'll be subtracting the A meter from here plus this A meter, making 2 from the 3. So it means that the dimension here with the black ink is going to be 3 minus what? 2A. And similarly, this will be the same as 5 minus what? 2A. If that is taken away. Remember, if this is the net of a cylinder, how do you call it? The net of a cuboid, like this, when we fold it up, we are forming open box, right? We are forming an open rectangular box, meaning there will be 5 sides, no 6 sides. So if you fold up this, we'll be forming this. Don't forget, this our longest side here will still remain here as 5 minus what? 2A. Don't forget, this is the length and the breadth. The breadth will also be holding in there as 3 minus what? 2A. Then as this is coming up, it is this that will be making it have a thickness. That will form our breadth. So we are going to have the length, the breadth, and the height. Sorry, this will be forming the height. So the height will be here. The breadth is the one we have here from the rectangle. That's the breadth, the length. Then when you form this and this will meet to be standing to form how tall the box is going to be on the ground. So if that is out of the way, we can say that the volume of a cuboid is length times breadth times what? Height. That is the known formula we use to find the volume of a cuboid. But in this case, it has its own dimension. So we can say the volume will be equals to 5 minus 2A as the length times the breadth as 3 minus 2a times what? The height. You see that? We are taking the length, the breadth, and the height. So we can multiply. So this will be 5 times 3, 15. 5 times 2a will be 10 a's. 2a times 3 will be 6, but negative. So negative 6a, negative 2a times 2a plus 4a squared. Then the a will now multiply. What will happen? You'll be having 15a. A times a will be a squared. Then let's combine this as well. We know this is going to give us 16a, because minus a minus 6a will be 16a. So we're having 16a squared plus 4a to the power 3. Why power 3? A squared times a. And we are asked to rearrange it in increasing order of the variable. So v will be equals to 4a cubed minus 16a squared plus 15a. Just like we are asked to be proved. So we are showing that the volume of this is going to give us this. And I guess the process leading to this is understood by you. Alright. Now, if we are asked to find the maximum, what do? At the maximum, we need to deal with differentiation. We need to differentiate this very one. So we can say that, where are we? This is question 1. So we are going to differentiate, meaning dv, dA, differentiation of v with respect to a. Don't forget the 3 come forward to give you 3, 4, 12. Subtract 1, square. It come forward, 32. Subtract 1 from the power, a. Come forward, plus what? 15. So this is the differentiation of the v with respect to a. But what are we looking for? We're looking for maximum. So we can say that at the maximum, we are going to have at the maximum or minimum, the dv dA, that's the differentiation, the gradient or the slope is going to be 0 at that point, at the turning point. You're going to get 0. So we are going to find the values of a when the dv dA equals to 0. So from here, we can say that 12a squared minus 32a plus 15 equals 0. This one is 15 times 12. Look out for the factors to get this. I think that will be a bit long. So let's go for the quadratic formula. So our a will be equals to minus b plus or minus. We have our b squared 4ac divided by what? 2a. In the sense of this a is not the a we are having here, but we are talking about the values we have in front, the coefficients a, b, c. So this a is the independent variable we are looking for. So a equals to b will be this. So negative 32 plus or minus the root of b, which is going to be negative 32 all squared minus 4a, which will be 12. Then we have this. So let's say 4 times 12. That will be 48, right? So let me have 48 times 15, so that I can conserve the space here, divided by 2a. And our a in this case will also be what? 12. Alright. Let's see this being 32 positive, plus or minus. Let's have the square of this. So when we square the 32, it will give a positive 1024 minus So 48 times 15 will also give us 720 divided by 24. We can have 32 plus or minus. If you subtract this, we have 304 divided by 24. So from here, we can have 32 plus or minus. The square root of this will be 17.44 into 2 decimal places divided by 24. So the next thing is to pick the first one to be our A1 should be 32 minus 17.44 divided by 24, or our A2 equals to 32 plus 17.44 divided by 24. So we are going to put that in our calculator to derive the value of the A1 and the value of the A2. So from here, our A1 is going to be 0.61. Our A2 is going to be 2.06. So now we know the values of A, that are the two values of A, which is the independent variable for the volume. So what are we looking for? We are looking for maximum. Let's find the maximum and the minimum. So we can say our second derivative, that will be the 2v over the a square. We are going to differentiate this very equation we have. You know, this is the dv dA. So if we differentiate again, that will be 24. Then the a will come. If we differentiate, minus 32. If we differentiate, 0. So this is what we are going to have. So let's test which of these values will give us the maximum volume. So I can say that when A1 equals to 0.61, the 2v over the a square will become 24, then minus what? 32. In place of a, we substitute our value for a and put that in the calculator. So if you do that, that will be giving you negative 17.36. So when your second derivative gives you a negative value, we are saying that that value is less than what? 0. That is proving that is the maximum point. When we get a second derivative to be less than 0, that gives us maximum value of our parameter. Then let's check. When the A2 is 2.06, our d2v dA square become 24 times 2.06 minus 32. Let's see what that will give us. That will be 17.44, which is greater than 0. So that gives us the minimum point. So if this is the minimum point, then we are going straight forward to the maximum. Not this value, but what value of A give us that. That is it. So all we can say from here is that the volume is maximum at A equals to 0.61. That is where the volume is going to be. So now what will be the volume itself? We know the volume has been given to us in the beginning after we find the length, the breadth times. Let's see that. So now we can say that the volume, which is V, I think in the beginning we had it to be 4a cubed minus 16a squared plus 15a, right? That was what we have. So at A being this, the volume become 4 into bracket 0.61 to the power 3, 16 0.61 to the power 2, 15 0.661. So So we put all this into our calculator. We can do it step by step, but we put all together. And that will be giving us 4.1061. But the question asks us to put it in the nearest whole number. So if we are going to write this in the nearest whole number, we are going to have 4 centimeter cube as the volume. So that's the volume, the maximum volume. Anyway, that will be the maximum volume that the cube, or let's say the open box that the water will make, the maximum volume it can accommodate will be 4 centimeter cube. I believe you get the concept. A bit longer, but I'm sure if you take your time, you understood every bit of it.